So we have this problem from a previous year, CBSE class 10. They're asking us to prove this quantity, this plus this quantity is equal to this quantity. Okay. So whenever you get these kind of problems, right, before you get to solve, just take a couple of seconds and think that how can you make it much more simpler. Okay. Do I need to use trigonometry or do I need to use algebra? Because it's mostly algebra if you look at it. There is only one function which is used throughout over here. So what I'm going to do is that even before I get started, right, what I'm going to do, I'm going to replace this as, I'll do a substitution. Let tan theta is equal to x. Let's do that. Let's remove that trigonometric functions and let's deal with algebra. Okay, so when you do that, what happens? You get x by 1 minus 1 by x plus you get 1 by x divided by 1 minus x. So this is much more simpler. Okay, let's go ahead and solve this and later we'll come back to trigonometry to deal with it. Okay, let's take care of the algebra part of it. So what do you get when you resolve this? You get x by in the denominator it will become x minus 1 divided by x, right, plus here you're going to get 1 by x times 1 minus x. Fair, right? So now what can I do? I can basically take this x to the numerator because it's in the denominator over here. So this will become x square by x minus 1, right, plus 1 by x times 1 minus x. Okay, now can I make this 2 the same over here so that I can take it out? Okay, I can take that one out and I don't have to deal with it. So what do? I just reverse this one and take a minus sign outside. So what I'm going to do, x square by x minus 1, I'll make a minus over here and this will become x times x minus 1. Done? Simplified. Okay, so now we don't need this x minus 1. Can I take it out? Yes, I can take that one common, x minus 1, right? What am I left with inside? I'm left with x square minus 1 divided by x. That is what I'm left with, right? Let's go ahead and resolve this. What do you get? When you take x as LCM over here, you will get 1 by x minus 1 outside and you will get x cube minus 1 divided by x. Done? Okay, till here it's good. Now what can you do with this one? Can you break it into factors, right? You remember that formula? A cube minus b cube. What are the factors of a cube minus b cube? It's a minus b times a square plus ab plus b square. Remember this formula from expansions? You can use this formula over here. So let's go ahead and break it. So 1 minus 1 and in the numerator it is going to become x minus 1 times x square plus x plus 1 divided by x. Leave it like that because you have an x over here. This gets cancelled. So what are you left with, right? You're left with, if I divide these by x throughout, right, you're going to left with x plus 1 by x. Look at it. That is what you're going to get. So you have solved the problem, 90% of the problem by using algebra. Now we get back to trigonometry. So we are going to use that and we are going to replace the value of x with tan x and go ahead and solve the problem. Okay, just give me a moment. So I'll just keep that. Okay, so you have got LHS. In terms of x, you got it as x plus 1 by x. Let's go ahead and replace. X is equal to tan theta. So replace it with tan theta plus 1 by tan theta. Done? Right? So now what I'm going to do is that I'm going to convert them. Plus 1, I don't have to worry about. I have already reached the plus 1 what I want. Okay? Plus this tan theta is sine theta by cos theta. And this is 1 by tan theta, which is cot theta. So I can write it as cos theta divided by sin theta. right? When I go ahead and resolve this, what do you get? I'm just going to do this part. 1 plus is already sorted for me in the proof, right? I'm going to resolve this. So what do you get? When you take a LCM, right, it's cos theta sine theta, and you're going to get 1 plus sine square theta plus cos square theta divided by sine theta cos theta. What is sine square theta plus cos square theta? It is 1, right? Again an identity, and you have sine theta cos theta in the denominator. Go ahead and put the inverse functions of that. You will get sec theta cosec theta is equal to RHS proved. So this is how you do it. So whenever you see similar type of functions on the left side, right, always remove them so that you don't waste a lot of time writing them in the paper. You can always do it with tan theta, but it takes a lot of time. And in a board exam, right, you need to save a lot of time, right? So that's why I used X and solved the problem algebraically and then came back to trigonometry and proved it, right?